In this style of programming, so far whatever we have done is called procedural programming. The concept we have learned is still same loops and everything is in the object-oriented programming also. It is in the procedure programming also. Only thing is we learn to divide our program in a smaller component, and so that it becomes more manageable. It's an extended version of functions. In function, you are only doing the processing. You're not storing any data. Or in object-oriented programming, you think in terms of objects and you store data and processing both in that particular object. Okay, so that is what the major difference. Why do we do that? That's because code becomes much more maintainable, much more modular, and each functionality holds the data in its own. You think in terms of now bigger and better building blocks like Lego blocks, where you're writing a big program. Think of it like you are developing a banking system in real life. In the banking system, imagine that you write one program and that program does everything top to bottom. It's going to be very hard to maintain because now you have to open the account, you have to checks and balances, you have to withdraw the money, you have to submit them, deposit the money. Everything, if you write in one program, is going to be pretty hard to maintain because functionality change independently. Sometimes bank apply different rules for deposits. Sometimes bank may say that, hey, you have to maintain minimum balance in certain type of account. Today we have saving account and checking account. Tomorrow bank, we have loan account. Tomorrow you have a different type of account. So if you just put everything in one program and the program runs top to bottom, becomes super complex and becomes very unmanageable, right? It's very hard to maintain this program. That's why when you write a small program, you do like this. And you have seen examples of all these days you have learned it. But another style that I call it object-oriented programming, you think in terms of objects. Everything is an object. For example, I'll give a couple of real-time examples. Let's say tree. I can see tree from my window. So I'll give an example. Like let's say tree. So tree is an object, right? When I say tree is an object, what does it mean? This tree, if you think, has both. It has data and it has some functionality. Right? For example, the data is all these absolute values like color of the tree, color of the leaves, number of leaves, number of branches, height of the tree, the circumference of the tree. All of these things that describe what tree is, right? You take human, we'll take, a human. You can describe the height of the human, your color, your hair color, your eye color, your education. All of these things are characteristics or data about that particular human, right? Similarly, as I said, the tree. So the tree has its own characteristic data like height, weight, color, anything that describes the tree, anything that describes the human, your name, all of that part. And then tree also has some functionality like tree grows, tree, we put water in the tree, we plant the tree, we water the plants, water the tree grows, tree shed leaves. Those are the functionality of the tree. Similarly, like take an example of another example. Let's say car. A car is an object, right? And every object has two parts, as I said, data, which is nothing but basically characteristics that describes a car, and some functionality, right? Or some people also call it data or features, right? And then you have some functionality, which in people call it like functions. It provides some service. It has some functions. Okay. What I mean by that is, take an example of car. A car has color. I'm taking some examples of this side, right? Car has color. Car has brand. Every car has a model, right? Car has number of wheels. Right? All these things, and many more, right? Describe what a car is. On the other hand, car has start button that describes that has a functionality. It has a feature. It's a service. It's a function. Car can stop. You can change, you can reverse a car. You can apply brakes, right? Or you can also say, if you apply brakes, then it will stop the car. You know, if you start the car, car moves, so car moves, right? All these are functionality of the car. So far, so good. Pranav? You guys can hear me? Anish?
Yeah, I understand so far.
Right? So every object in this world, if you think in terms of today, you know, after this class, take a time and think, what are the objects do you see? Right now, you may be seeing it, the table or chair, television in your room, TV in your room, right? Your iPad. Every object, everything is an object. That object has certain characteristics or features, and it does something. It provides some functionality, like switch on, switch off, you know, play video game, all those type of things. And then color, those literally the nouns are in a short way, in easy to remember. Mostly the nouns are the characteristics or data, and then verbs are the features or functionality of the car or the TV, like switch on the TV, move forward, play forward, stop, you know, all those on your remote. All these are functionality on the object. Now, what it has to do with programming? Now, suppose you want to create, suppose you want to, you know, write a functionality. Before I go there, actually, this functionality, these functions actually work on this data.